Welcome aboard, November 147, Bravo Romeo. Today we're going to be demonstrating the automatic calibration capability of the on-speed system. First thing to keep in mind is you want to make sure on your phone or your iPad or your tablet, you want to go into your display brightness, make sure everything is turned up full bright, and then if you have an auto lock feature, you want to go ahead and disable that, so I have mine set to never. Next thing I want to do is I want to make sure that I am in airplane mode and I have data and I have Bluetooth turned off. That'll avoid any unnecessary notifications with my iPhone, which could interrupt the process. And then the next thing I want to do is I just want to make sure I go to settings and connect up to my on-speed network. So I'm going to connect to on-speed via Wi-Fi. And then I'm going to open up my browser and I'm going to go ahead to type on-speed local because I'm using a iOS system. And that'll bring up the Wi-Fi gateway homepage. The next thing I'm going to do is go to my settings page, and I'm just going to confirm everything is correct. We're going to assume already for this demonstration that we have flap settings in the system. So I have 3 flap positions in my airplane, so I have 3 flap curves. I've gone in there and I've measured my sensor value at each curve, so 210 for flaps up, 387 for flaps 20, and 618 for flaps 40, and that's in flight under air loads. You can also simulate that in the hangar by pulling up on the trailing edge of the flap. So I built my 4 curves, and now I'm going to go ahead and populate them with data.
Approach, radar contact, maintain VFR the east training area, out to your discretion.
What I want to do here is I want to make sure that under my EFIS calibration data source, I have EFIS selected. If I've inadvertently selected on-speed internal IMU, I'll change that to EFIS, and then I'll go down and I'll hit save down at the bottom. Now, iPhone-ism, the first time I hit save, it just brings up the browser menu. It doesn't actually input anything. So the next time I touch the phone, the save button becomes hot, and then notice that it says configuration saved. Now we're going to go ahead and turn to the left here, just to get set up for our auto calibration run. I'm going to go into settings and I'm going to hit the AOA calibration wizard, and that's going to pull up the first page of that display. And a little hard to read here. We'll hold off until we get through the sun. Let me expedite the turn. And now let's take a look at this. So we need to know the max gross weight. We need to know our test weight. We need to know our best glide speed in knots at max gross weight and our airframe limits. So those numbers for the RV4 are 1,500. We're currently 1,315 pounds. My best glide speed in this configuration is 78 knots indicated airspeed, and my airframe load factor limit is 6. So I put all of that in, and then I hit the continue button. The next thing that's going to pop up are a set of instructions. Now notice what the instructions are telling us to do. The first thing is we need to make sure our flaps are set and we don't change them until we've actually saved the calibration. We want to coordinate as much as possible, and we want a very smooth pitch input, and we want to prioritize that over deceleration rate. We have a deceleration display on both our phone and on the optional M5. I have that selected just to my immediate left, okay? The system is looking for the breakdown in longitudinal stability, or the nose pitching forward after the stall. So that'll actually take it out of the calibration mode. If that doesn't happen, we have a backup procedure to accommodate, but less than desirable. So those are the instructions. That's all that's on the second page. We'll go ahead and hit the continue button, and now we're up to the actual auto calibration page itself. You can see it says flap position 0 degrees. All right, I've got my arrow, which is my deceleration trend indicator, smoothed, and I'm ready to actually fly the auto calibration run. So what I want to do is accelerate the airplane out to a VNO condition, which is the top of the green arc. So I'll just push the power up to wide open throttle, and I'm level. And I'm going to be looking for about 180 indicated here. 175 is certainly close enough for government work. I'm actually trimming the airplane for a VNO condition. As I approach 175, I'm going to use the data mark feature to get a data mark in my V3 data, and then I'm going to press the record button. So standby data mark 3, 2, 1.
Data mark.
And now I press the record button. Now I start pulling the throttle back slowly. Now all I'm doing is looking out the window, and I'm maintaining a constant picture. As the airplane is fast and starts to decelerate, your pitch really doesn't change very much.
For the visual approach on 012.
So now I'm just starting to squeeze the stick a little bit with my pinky and my ring finger. I'm still pulling the throttle back, and mark the throttle is back. Took about 10 to 13 seconds to pull the throttle back. And now as the airplane decelerates, I start to shift my focus a little bit to the deceleration display while I'm still looking out the window, keeping a constant distance between the horizon and my nose. But as I approach the green band, the nose is going to start to rise just ever so slightly. So what I'm going to do is kind of keep this pitch picture until I get to about an L/D max condition, okay? And I'm going to hear that today because I already have a calibration in the system. But you can see the nose is up just slightly now. And now if you look at the deceleration display, I'm right at 1 knot per second, which is about optimum. So now, once I'm slower than L/D max though, the pitch rate has to increase. The nose is now approaching the horizon. The nose is now over the horizon. As I get to the stall, I'm going to actually have to increase that pitch rate to keep that nice smooth deceleration going into the stall. And there's our stall. I look down, I see the system has got a blue record button, and I've got a good curve down at the bottom. So the first thing I do is assess my curve. And my R-square value is 0.9983. It looks good. I've got a nice convex curve. That curve is very flyable. So the very first thing I'd like to do is just save that data to the file, and I'll do that because then if there's any issues, I can get good tech support. And the next thing I'll do is I'll take a happy snap of the phone itself, just so I've got a picture of the curve post-flight, and I've got a picture of the data post-flight. If I want to run another one of the, whoops, and I'm trying to fly and work my iPhone at the same time, and if I want to run another one of those, I'm just going to refresh the system here. And I can run as many calibrations as I want. If I actually want to save that calibration, then I'm going to use the save calibration function, and I'm going to wait, and I'll get an indication on the Wi-Fi gateway that my calibration has been saved.